Hello everyone and welcome back. Today we have 26 remove duplicates from sorted array. It says here that we're given an integer array nums which is sorted in non-decreasing order and we are to remove the duplicates in place such that each unique element appears only once. The relative order of the elements should be kept the same, then return the number of unique elements in nums. So we have these two examples here. Let's start with the first one, shall we? We have this. We know that this is sorted. So if we see a 1, we may subsequently see a 1, but we're guaranteed that if we see another value, such as a 2, we won't then again see a 1. That will not happen because this is sorted. All right, so then couldn't we do this? Couldn't we keep track of the last seen value? Okay, the last seen value can be initialized to whatever the first value is, which happens to be 1. Then we have the first position already set up. The first one can't be a duplicate of itself, so it can stay as is. The last value here is 1. And which is at index 0. The next insert position is index 1. Then, starting from index 1's value, we can check, is my current value, if I'm here, is my current value a duplicate of the last seen value? In this case, it is. So insert remains the same. However, our pointer moves right down. Okay? And once we're here, we can say, hey, all right, now I'm at index 2, I have value 2. Is this matching my last seen number? It is not. It's not a duplicate, so we can add 2 to where our next insert position is, which is index 1. So we added 2 here. Okay, and by the time we get here, we would say, you know what, this is a new value, which is not a duplicate, so let's update last to be my current value, the new value, and the new index position to be 2. But of course, this array ends, and then at this point, insert is 2, and the number of unique elements is 2, and so we return a 2. Now, if we look at the second example here, we see that once again it is sorted and we can once again keep track of the insert position and the previous values to update the unique elements in place while maintaining the relative order of the numbers seen, just like so. So this is sorted and we maintain the relative order. Okay, so let's do that again. Let's start at the first index. The first index has 0, all right? The first insert position will be 1 if whatever is at this position, which starts at 1, doesn't match the value which is noted as the previous value, which is 0. Okay, so this is done, and we officially start at the first index and say, my value is 0. Does that match the value which is previous? It does, so all right, I'm a duplicate, so nothing to do here. Let's move on. Here we can say, so 1 does not duplicate the previous value, so we can add 1 to the next insert position, which is at index 1. So that goes there. And then we can increment the insert to the next position and make sure to update saying, all right, the new previous value to not duplicate is now 1. Okay, is now 1. All right, and then we can continue moving right down. 1 is a duplicate of the previous value, So we do nothing, we keep moving. We're at index 4. 1 is once again a duplicate of the previous value, which is still 1. We move again, and here we see that once we're at index 5, we do see a value which is not a duplicate of the previous value. At this point, we can take that value 2, add it to the next insert position, which is at index 2. So let's do that. Let's add the 2 over here. And then make sure to increment the next insert position to be that after the previously inserted position, and also update our previous value to B2. Okay? And then we can continue the same process. We move to the next position, which does duplicate the current previous value. We move on. We once again hit a new value. Great, same process here. We add this value to our next insert position, which is a 3. Great. Once we used up that position, let's increment it and make sure to add or update the previous value as our current value. Okay, once again, let's move on. And this is a duplicate of previous. Move on. And we're finally at our final number, which is not a duplicate. So once again, we update the next insert position, which is at index 4. So let's do that. And then increment this to 5, update the previous to be our current value 4. All right, and so we're left with the insert position 5. If we have any more duplicates or any more other unique elements, we would be adding it at index 5. But because we're ended, we have total 1, 2, 3, 4, 5 elements which are unique, just like we see here. And then we can return 5. All right, finally, the fun part, the code. Can we translate what we just did here into code? Of course. Let's have some variables. We have some insert position, which will initialize to 1. We're doing that because we're going to remember the previous number. Let's call it last this time. The last number as whatever is at the first position. So the first position number is already covered, so we can start inserting from the position after this. And then we can check every number in nums, but remember, we don't want to consider the first one. The first one can't be a duplicate of itself. We want to start from the second number at index 1. And then for every num, what we're checking is if and only if this current num does not equal whatever's remembered to be the last number, then only do we insert in place into nums. Remember, we're doing this in place. We're going to insert in place into nums at the next insert position, whatever is the current number. And once we do this, make sure to increment the insert position. So we insert to the right of us in the future iteration. And also don't forget that now the last should be updated to whatever was the current number. Okay? And then at the end of this, I will point to the next insert position, which will also be equivalent to the total number of unique elements that we have in num. And so we can return I directly. Let's try that out. Okay, let's submit. All right. And yeah, that's once again 26. Remove duplicates from sorted array. We have our time as linear. We're visiting each number at most once. And then space is, let's see, we're only holding constants, so that is O of 1 constant space. Okay, thanks so much. Happy coding. See you next time.